Well, let's pick up where we left off with the muscle contraction and all this fun stuff that's taking place when contractions occur. And the last thing that we covered was, okay, we get a muscle contracting, but it can't stay that way. You know, we can't, really smooth muscle is the only one that can withstand tetanus, okay? So we do want the muscles to go back into relaxation, or hopefully what you're going to begin associating with resting membrane potential, okay? When the muscles go back into relaxation, we do move back to that fiber being at rest, and when at rest, we're going to find that we have resting membrane potential. Now, what that tells us is it is going to have the potential to do something. And in the case of skeletal muscle, that means the potential to work. All right? So, when we talk about this movement that occurs, we have talked about it in relationship to one fiber. You guys remember when we talk about one fiber, this means that I'm at the level of my muscle cell, muscle fiber. I have a nerve ending that meets it, okay? I've got my synaptic cleft. I've got all of these activities that are going to take place in the cleft, okay? And this is looking at contraction of one fiber. Now, if you remember, a muscle is not just one fiber. It's this makeup of all these fibers that are bundled together. But here's what we know, okay? We know that if we are looking at this physiology, at this activity, at the level of this muscle cell, we're going to be able to determine what's going to happen to the muscle as a whole. So when looking at what takes place with this muscle cell, and we have the nerve that's innervating it, we get an impulse, all those activities get started. Do you remember how this that's right here. Okay? And we had our resting membrane potential, which was way down here at the negative. And then as we move up towards becoming positive, okay, what's happening at this point at the cell? And depolarizing, what ions are moving in? My sodium. Okay? And if I go up towards positive to a certain point, I reach my threshold. Does everybody remember that? Mm-hmm. If I reach threshold, what will occur? I won't be able to stop it.
Contraction.
My contraction. Okay? So, if that takes place, this muscle is going to contract no matter what. And then we go into our repolarization. Do you happen to remember which the protein in the membrane that's going to be helpful in balancing the ions? My sodium potassium pump. Okay? That sodium potassium pump is going to help to repolarize because sodiums are going to get moved out of the cell. Potassiums will get moved in, and I will be able to bring my muscle, the cell, back to rest. Meaning, inside negative, outside positive. So when the impulse occurs, what we find is we begin to get that impulse from the nerve. We're going to see that our nerve is at rest. Once we begin to have the depolarization take place, if we reach threshold, it's going to contract no matter what. Once it contracts, hopefully we're going to see the repolarization and the cell go into relaxation. For the skeletal muscle, we say this is a muscle twitch. All right? Now, not simply a muscle twitch. Okay? We're talking about this happening at that one fiber. And that one fiber only, okay, is impulse, or do you think impulse to one fiber, one cell, is enough to make the whole muscle contract? No. All right? Sending the impulse that's only affecting one tiny little fiber, okay, that is not enough to make this entire muscle contract. So, what's going to have to happen? At the point where the nerve meets the fiber, all right, we have learned that this is termed the synapse. But do you guys remember hearing me say, we are going to learn that this is the motor end plate? Do y'all remember me saying that?
Motor end plate?
Motor end plate. Our neuromuscular junction is a motor end plate. Let's just think about that for a second. Motor, because it makes it move. And I'm at the end of it. Does that make sense? So, these motor units, one of the things that I've tried to point out is that every single fiber has a nerve to it. Okay? It enters at some point on that fiber. So, if we look at just one fiber with the one nerve, okay, we're going to find that that's just innervating the one. But do you remember how I said that if we look at the muscle as a whole, there's a big nerve that enters along with the blood supply. You guys remember that? Okay? And branching begins to take place if my fibers are in fascicles. That means I get a branching to every single one of them. So therefore, I've got a motor unit. So if I have my fiber, and then if we're looking at this being a fascicle, okay, and fibers are all innervated by that same nerve, okay, what are the chances that that impulse is affecting more than one of the fibers? Very high. So that means I'm going to see that a lot of my muscle fibers from the one impulse, most likely the same things happening consecutively with all of them. Okay? So if I have now increased my number of fibers that are innervated with the impulse coming in, what do you think I've done to the chances of this muscle contracting? Have I increased or decreased the chance? I've increased the chances. So that's pretty much what happens. Because if you think about the structure that we're given, in the structure of muscles in relationship to their nerves, see the yellow line? See the yellow line? Okay. See the yellow line? All right. The yellow line? The yellow line? Okay. This is the way it works. This yellow line that you see here, that you see there, that you see here, okay? Y'all kind of following? These are the large nerves, okay? These are the nerves that will branch into some of the medium nerves, and they will move into a muscle. For example, all right, my gluteus maximus is not on here, but gluteus minimus is, okay, and it would have that medium nerve going into it. Just that one. But once it enters, it branches to every single fiber. So let's say that we had an impulse for our, let's say it's from our higher order thinking, okay, that's going to make the glutes move, okay. Chances are that impulse that's traveling the nerve going to the muscle, it's going to hit every fiber. And therefore, the activities that will take place cause that muscle to contract. So, once we reach our threshold, this portion right here, we have what's called the all or none principle. Meaning, if the impulse is strong enough and it makes all of those fibers reach threshold, that muscle is going to contract, and you cannot stop it.